today we are doing labs 8.1. We are investigating what happens to the mass of matter when it changes phase. Okay? And on your hypothesis, I want you to choose one, either A or B. A says if I measure the mass of ice in a bottle before and after it melts, then the mass will be different. If I measure the mass of ice in a bottle before and after it melts, the mass will be the same. So I want you to choose one. Okay, and now let's go through. Okay, so I have this bottle, and it has ice in it. Okay, I'm going to measure the mass of the bottle with the ice. Okay, I'm going through the procedure, so you need to be kind of writing this down. Okay, so I'm measuring the mass of the bottle with the ice, which is 32.2 grams. Okay, I'm going to write that down because that needs to go into your data table. 32.2 grams. Okay, now I'm going to melt the ice.
Is that at the starting mass?
Yes, that's the starting mass.
And we're doing data and procedures at the same time?
Yes.
Was it 32.2?
32.2. How do you think I'm going to melt the ice?
Probably burn it?
No, we're not using fire, not with a plastic bottle.
Oh.
How?
Beat it.
Huh?
Are you going to beat it?
Just cover your
Yeah.
Oh.
What about this?
Oh, you're going to make kinetic energy and then it's going to get all hot.
Yes. We're going to kind of roll the bottle around. We're going to do this a little bit. We're going to do anything we can to melt the ice without using fire. Okay? And now I'm going to pause the video while... Okay, so over the last 5 minutes while I had the video paused, I melted all of the ice. You can see it's water. It's all water now. And what is on the outside of my bottle? It's sweat. What's another name for sweat like that?
Like
Condensation. Okay. Do you think we need to leave the condensation on there, or you think we need to wipe it off?
Wipe it off.
Why do you think we need to wipe it off?
Because it's extra mass?
Yes. So let's wipe any condensation
Wait,
off
how does
the
the
bottle.
condensation get from inside the bottle from to the outside?
Okay. Condensation happens when you have too big of a difference in temperature. So everything inside the bottle was too cold. It cooled the air around it and made more mass on the outside.
Okay.
Okay? So I'm going to wipe any condensation
Could that be
off the bottle before I weigh it.
Could that be step 3 is white?
Yeah, it can be considered step 3. If you want to change step 3, instead of weigh the bottle again, wipe off the condensation. Okay, I'm going to go ahead and weigh it a second time. Let's see what we get. Okay, it is 31.9 grams. So we went from 32.2, oops, it just went up 32.0. So 32.2 to 32.0
I think
grams.
most of the mass comes from the bottle.
Yes, it does. Okay, so now I'm going to go back.
What was the mass?
Mass was 32.0. Okay, I'm going to go back to our thing. Okay, so right here in your data table, you've got the starting mass of ice, 32.2. Ending mass is 32.0. So did the mass change?
Yes, by 0.2.
Okay, but yes, it did by 0.2 grams. Okay. And look at analysis question number 1. Why do you think a sealed container was used for this
So the
experiment?
water
So the
would fill up.
condensation.
It would have went everywhere we wanted it.
Well, it would have gone everywhere. What were you going to say, Raleigh? Oh, what, Carson?
Was the lid on it when you went first?
Yes, the lid was on it.
So the water would not evaporate.
Yes, TJ, so the water would not evaporate. And so the ice will not have, yes. So you would not have any evaporation, okay? Because if you have evaporation, what are you losing?
Mass.
You're losing mass, okay?
So ice weighs more than, like, regular water?
We're going to talk about it in just a minute. Okay, and then we said, and we've already answered this one, analysis question number 2. Why is it important to wipe off any condensation from the bottle?
Because it's extra.
Because it's extra mass, right.
Number 1 is so the water would not evaporate.
How do you spell extra?
EXTRA.
I just put BC. I'm doing my work, Davis.
I know you are. I'm proud of you. Okay, number 3. This is for you to answer because we're going to do this tomorrow. What do you think will happen to the mass if we freeze the water in the bottle?
Well, it'll gain more mass. Oh,
Do you think it will change or do you think it'll stay the same?
So is this like what we think will
Okay,
happen?
what you think will happen. You're kind of doing your hypothesis for tomorrow's lab, okay? Or actually for Thursday's lab.
Well, I think we definitely lost some mass.
A little
So I think
bit,
if-
but we'll talk about that in just a
So I
minute.
think that if we did do it again, it'd probably stay about the same.
Okay. TJ, what's your question?
If we peed outside.
Oh my gosh, let's not ask that on video, please.
Wait,
You're on
video?
video?
Yes, I'm videoing. Okay.
I thought it was pretty straightforward.
I know. Wait till after the video and then you can ask
Smart
me.
question. But what if they were to ask?
Isn't more mass from the, like, when it's more condensed, and the molecules are close together? Is that creating?
Okay. Think about, okay, what happens to ice, or what happens to water when it freezes? Does it become more or less dense?
Oh, no, less.
Why does ice float in water?
Water bubbles.
Because it's less dense. Okay, so it expands as it freezes, which is why when you put a bottle of a liquid in the freezer, like a Coke, what happens if you don't get it out and it freezes? It's going to explode.
It
Okay.
stays like water until you touch it.
Okay. We're not getting into that. Okay, so let's look at your vocabulary for the conservation of mass. Do y'all remember what this is?
Nope.
Conservation means it changes or something?
Okay. Y'all remember when we did conservation of energy, it was matter cannot be created or destroyed.
Yeah, that's exactly what it says.
Mass cannot be created or destroyed.
Oh, wait.
Mass cannot be created or destroyed. Because what is mass?
Everything.
Mass is matter, okay? So conservation of mass and conservation of energy are kind of the same thing.
So just like energy, it can't be
Someone gotta write a paragraph.
Yes, now you need to write your conclusion. Remember, start with your question, then write your hypothesis, then tell me about your results, okay? Why do you think we lost a little bit of mass when we
because of
melted it?
the condensation.
Okay, there could have been a little bit of evaporation and the condensation that came through.
Is the video ended yet?
No. We could have had a little bit of evaporation. I mean, this is a sealed bottle, but it's not airtight. Okay, so we could have had a little bit of evaporation. Okay, so now we're going to end the video.